Hello guys, again this is teacher Seth. Welcome back. In this video, I'm going to share with you guys on how to find the LCM and GCD of algebraic expressions. Remember, in various questions of secondary level, you might find there that you are having various expressions where you are supposed to apply the knowledge on LCM and GCD for you to solve that given expression or equation. Therefore, be well set as we are going to start. I want us to consider the following two questions. First of all is question 3 in this paper that I'm having here. And the question 3 is here. Question 3 is here, and it reads, find the LCM of x squared plus x, x squared minus 1, and x squared minus x. So let me write that given information. Let me write the given information. It was question 3, and the question was saying that find the LCM of, it is x squared plus x, the next one is x squared minus 1, lastly it is x squared minus x. That is the given information. So always remember that for you to proceed with this question, then it is good you factorize the given terms so that as you shall be doing your working, the work becomes simple. So like the first one, the common term is x. X goes into x squared x times. X goes into positive x, positive 1 times. Then for the next one, it is x squared minus 1. Remember, 1 squared we still just get 1. So this is like, it is the difference of two squares. Remember the information that we learned in our last class. Don't forget, because it is what we are now going to apply here. If you did not see that video, then just go and then you refer back. Remember we said that if you are having any difference of two squares, so for you to factorize, it is just the sum and the difference. It is just the product of the sum and the difference of those two variables. So the same applies in this equation, that in this expression that we are having here. So for us to factor out, it is just the sum of x and 1, and then times the difference of x and 1, and we have factorized it. Then for the remaining term, the remaining expression, x is common, x there is x there is 1. So after now reaching that point, we can now find the LCM comfortably. And let us use the table to find the LCM. So we'll have x plus 1. Then the next term is x plus 1, x minus 1. And then lastly, it is x minus 1. So by using table, that is how it normally works. So what is the common factor in any of the two? X is common, it is here, it is also here. So x and this one cancels, will remain with x plus 1. X doesn't go here, so we rewrite the whole thing. X goes here, it will cancel with this one, so it remains with x minus 1. And then any common factor here, let us first of all go by x plus 1 because it is here and here. So x plus 1 goes here how many times? 1. Goes here how many times? X minus 1. It doesn't go here, so we rewrite the whole thing. Then finally we are remaining with x minus 1. So x minus 1. Because here it is 1, we are good. We can even rewrite that one there. And then x minus 1 into x minus 1, it is 1. X minus 1 into x minus 1, it is 1. So that means that the LCM is the multiple of these factors outside here, which is x times x plus 1 times x minus 1. Remember this term that I've bracketed using the square bracket, it is just equal to this factored form of the difference of two squares. So meaning we can rewrite this one as just x squared minus 1, so that it is x into bracket x squared minus 1. If we can open out again now the bracket, it becomes x cubed minus x. And we are done in finding the LCM. We are done. Let us also look at another question, like question 6 in the paper that I'm having here. Well, the question 6 is there, and the question reads, find the GCD of that term and that term. Hence, factorize completely the expression 144 x cubed y squared minus 81 xy power 4. Now, if you see the word hence, what does the word hence mean? It means that from the given information that you are supposed to work first, then you can continue and use that information that you have found to deal with the next question. So in this case, I want us first of all to find the GCD of these two terms, and then from there we'll refer back to our question, what it is saying. So let me first of all write the information that we are having. So that is question 6. The question is saying, find the GCD of, we are there having 144 x cubed y square and 81 x y power 4. Right. So let us use the table to find the GCD. So we will have 144 x cubed y square and then 81 x y power 4. Now we are using the table. So let us consider the coefficient 144 and 81. Which is the factor that goes in 144 and 81? That is 9. 9 goes into 14 one times. Remainder 5. 9 goes into 54 how many times? 6. And then we rewrite x cubed y square. 9 goes into 81 how many times? It goes there 9 times. Then we rewrite x y power 4. Okay, so we are done. We don't have any other common factor of 16 and 9. So we proceed to the variables. Let's consider the x variable. We are having x cubed and x. Which is the common factor? It is x. X goes into this how many times? It is x, 16, x squared, y squared. So that x times x squared, we get x cubed. And then you can see x and x will cancel, so it becomes 9y power 4. Then in the remaining variable, that is y. So y squared and y power 4, which is common factor, it is y squared. So if we cancel out y squared and y squared will go there, so we remain with 16x squared. Then y power 4 divided by y squared, we remain with y power 2. That is it, y power 2. So from there now, it means that the GCD of these two terms here is the multiple of those factors. So it is 9xy squared. That is the GCD. Now let's go back to the question. The question was continuing to say, hence factorize completely the expression 144x cubed y square minus 81xy power 4. That is the information. So from there it means that now for us to factorize, we are supposed to use the given information, but what are we factorizing? It is 144x cubed y square minus 81xy power 4. So as we can see, the first term is just similar to what we are having here. The second term is just similar to what we are having here. So meaning the GCD is the common factor, and that is 9xy squared. But the question is, it goes here how many times? Of course, from here, it means that it will go here these times. So it is 16x squared. Then we subtract. Again, 9xy squared goes here how many times? Of course, it goes there these times. So it is 9y squared. We are almost done, but I want us to look here keenly. This seems like it is just the square of some value, and that is 4x we square. The same here it looks, it is the square of a certain value, and that is 3y square. Don't forget, again, from our previous video, we said that we can rewrite, remember? This is a reminder. We said that x squared minus y squared can be factorized as x plus y and then x minus y. So if we take this to be our x and this is to be our y, then that means that the bracketed terms now, if we factorize the bracketed term, then we will be having the sum of x and y, which is 4x plus 3y. And then we multiply it by the difference of x and y, so it is 4x minus 3y. And then don't forget that we had here an outside bracket term, that was 9xy squared. So by reaching there, it means that we have factorized this expression, and its factorized form is here. It was looking like the work was tedious, but it is just simple if you remember those expressions that we had solved in our last video. So if you haven't looked at that video, please go back, then you view the video, then you can subscribe it. Again, in this video, please subscribe, like the video, share it with your friends, and feel free to comment where necessary. Thank you for watching. Bye. See you next time.